Welcome to Xamarin University. This session is XAM130, XAML in Xamarin.Forms. Please be sure to download the class materials from the Xamarin University website. This class will go into how to build pages in Xamarin.Forms declaratively using XAML, the markup language created by Microsoft for their various platforms. We've got three main objectives to cover. First, we'll cover the basic syntax and usage for XAML. If you use XAML on other platforms, this should be fairly familiar, as the format and the usage is fairly similar and predictable. Next, we'll look at how to name elements and support adding behavior to the things we've created in XAML. And then finally, we'll get into how to customize the XAML for a particular mobile platform, and look at some of the extensions you can use to provide runtime values to XAML. One thing that we're not going to cover here is data binding. That's the next session that you're going to want to take after this. XAM310, and that covers the data binding system. Let's get started by looking at the structure and the syntax of XAML. First, let's talk about why you might use XAML to create your user interfaces. What are the benefits and the drawbacks? And then we'll look at the basic structure of XAML, and we'll talk about the specifics of Xamarin.Forms. So what you've likely done up until now when creating Xamarin.Forms projects is used procedural code to create your user interface. And this is where we construct the objects in code, and then we connect them together by adding them to collections, wiring up events, and so forth. This approach works. You can continue to use this if you prefer. However, it does have a few drawbacks. Often, the creation and the setup of the UI is a significant block of code. And that makes the code larger, and it makes it harder to picture what's being created. Since the UI visualization code is mixed in with the behavior, it can be harder to separate the two and map out for new developers or even maintenance later on. Also, visual things like fonts, colors, etc., they can be harder to change later on if you don't adopt a resource approach. Having to search through the code looking for color references can be painful. Also, although there's no designer tool support for Xamarin.Forms at this point, there very likely will be at some point in the future, and when that happens, it'll be possible to begin to divide up the work so that a professional designer works on the markup and a developer works on the code. This is similar to the model often taken in the HTML world. There are still times where you will need a code-based approach. For example, dynamic user interfaces where the controls, not necessarily the data, but the actual controls that are presented, change based on runtime information. Most UIs don't fall in that category though. We're going to talk about XAML. This is a markup language originally created by Microsoft to describe user interfaces in WPF. When Microsoft started designing XAML in 2001, which is when the Avalon project kicked off, which is the code name of WPF, they pulled from a variety of internal teams for advice. And in particular, they took a lot of hints from the DHTML group, Dynamic HTML, which was defining the HTML specifications for Internet Explorer. This time frame is important. A lot of people ask why Microsoft built XAML at all. Why not just use HTML and CSS? Well, it becomes clear when you realize that XAML and WPF was being designed long before HTML had solid standards. CSS didn't really exist yet. Most browsers interpreted HTML slightly differently. This is the time when Windows XP was just being released and Internet Explorer 5. Now, as a result, it just wasn't mature enough, and it didn't really offer the power and the flexibility that we see today. However, there were several key benefits that were recognized in the HTML design. First, markup languages are toolable. And that means we can create UI design tools and programs that emit markup, and that keeps us from having to get into the low-level details. Second, if we want to get into the details, it's still human readable, so we can hand edit it and look through it to understand the UI that it describes. And finally, markup languages tend to be extensible, and they support new tags that were not originally created as part of the language. These are all important key benefits, and they all extend to XAML when we're creating our application UIs. So enter XAML. XAML stands for Extensible Application Markup Language, and it was created by Microsoft specifically to create UI graphs and things like Xamarin.Forms. Now, as I mentioned, XAML started life with the WPF project at Microsoft. This was finally released in 2006 as part of the .NET 3.0 or NetFX, which is a much better name, but the .NET 3.0 release. It was then also used with Silverlight, which stuck around for a couple years, and is currently used by WinRT for both .NET and C++ applications. And finally, it's also currently used with Windows Phone to create mobile UI screens. And now, of course, you can also use it with Xamarin.Forms. XAML is used by every major application platform used by Microsoft today. It's very mature, is highly extensible, and is easy to understand because it doesn't introduce its own tags, but instead uses the underlying object model for the UI screens being designed. And as such, it's a great way to describe your Xamarin.Forms screens. There are three primary benefits we get out of using XAML, which address the concerns we raised with building our UI and code. First, there's a potential to introduce a designer role into the development workflow. By this, I mean another team member that designs the screens for you. This role can be generating UI assets and screens that are used directly in the development process with little to no involvement from the developer. Second, it integrates nicely with designer tools. Microsoft has invested heavily in this. They've actually written 3 different designers at different points. Today, they used Blend for everything, and this is integrated into Visual Studio and is still getting updated. Unfortunately, Xamarin doesn't have a designer yet, but we will at some point. And today, we edit the files as XML text with some limited IntelliSense. And then finally, and most importantly, it encourages a separation of UI design from the behavior of the UI. And that makes it easier to adjust the UI visuals, add animations, change fonts and colors, all without impacting our logic or introducing bugs in our code, since the UI design isn't contained in code. If you've done any Microsoft UI development in the last few years, then it's likely that you've done some XAML already. The XAML used in Xamarin.Forms follows the XAML 2009 specification published by Microsoft, and it includes almost all of the features described in that document, including things that aren't supported in Microsoft's implementation yet. So the structure of XAML and how it works will be very familiar to the Microsoft XAML crowd, but the controls and the elements that you use to build up your screens will be a bit different. As an example, here we have a simple page defined for a WinRT application that displays a text box, a password, and a button, and they're organized vertically. The root container is a page, and we use controls and layout containers that are specific to the WinRT world. This same structure could be created for WPF, but some of the controls and the properties would be different. For example, in WPF, the root element is most often a window instead of a page. That same page in Xamarin.Forms would look something like this. We use the same control for text entry in both cases. One is marked as taking a password, and the button here has a text property, not a content property. The root element for most of our Xamarin.Forms pages will be a content page instead of just a normal page. But you can see the similarity and how the XAML definitions themselves are exactly the same. The key difference is in the controls that are being used. And that means that most of your Microsoft knowledge will transfer straight over. Here's a list of some of the features in Microsoft XAML platforms as compared to the features in Xamarin.Forms. You can see both will support the XAML 2009 specification. Xamarin.Forms only supports the box view, which is a subset of the rectangle shape, and we can create custom renderers to fill in that gap, however, on the Xamarin.Forms platform. Triggers are supported in WPF only for Microsoft. Data binding features are not completely supported in Xamarin.Forms. For example, the update source trigger and the relative source bindings are not currently supported. Control templates are not present in Xamarin.Forms because the visual tree is native and not controlled by forms, so instead we use custom renderers. And we do not support layout transforms in Xamarin.Forms, which is a feature in WPF. So let's look at how to add XAML content into our Xamarin.Forms apps, and we'll cover the basics of XAML for those of you who have not done much with it. To add a XAML page to your application, you'll typically start with a built-in item template. Xamarin supplies two of these out of the box. We have the content page, which creates a new page, and this is the one that you'll use most often, and is the one we're going to focus on here today. Content view adds a reusable view. This is similar to a user control in the Microsoft world. It creates a composite control that couples some behavior and UI together and can be placed into an existing page. When you add content page items to your application, you will always want to add them to the cross-platform project, typically the portable class library. And this is where you typically place most of your code today already. So you cannot add the Xamarin.Forms XAML pages into your iOS, your Android, or your Windows Phone projects because the tools aren't supported in those project types. Once you add a new content page into your application, it will add two files that are tied to one another. First, you'll get a .xaml file. This is the XML markup, and it will contain the UI definition. It will be stored as text in your application resources and parsed at runtime to create the page. Next, you'll also get a .xaml.cs file, which is the code behind file associated to the markup. This is where the C# behavior and logic that drives the screen will be placed. These files are related together, with the XAML page being the root element. The association is visualized in the solution using a disclosure arrow that you can open and close to see the underlying code behind file. Okay, so let's look at some XAML by describing a UI that we're all familiar with, PhoneWord. This has four controls in the UI. We have a label, so we can enter the phone word. We have a entry, which is where we're going to type. And then we have two buttons, one for translate and one for call. Let's cover the points that you need to know. Again, if you've done XAML programming before, then this works exactly the same way. XAML is very simple at its core. It's really just an object serialization technology. It's used to create an in-memory graph of objects from an XML file. Keep in mind, this is XML that we're working with, so the case matters, and it has to obey all the rules of parsing XML. Tags have to be matched, some characters have to be escaped by hand in order to be used. Element tags are going to create objects. Conceptually, you can think of this as a new operator. Attributes will set property values or wire up events. And parent-child relationships in XAML are translated to ownership relationships for the objects being created. The build action should be set for you by the templates already, but if you ever add in an existing XAML file into a project, then you might need to set these values yourself. Also, if you're upgrading an existing Xamarin.Forms project to a 1.3 or beyond, then this will also need to be updated. Originally, Xamarin.Forms used the MS-build compile build action. However, with the release of Xamarin.Forms 1.3, this changed to the update design time XAML for the custom tool. Any existing projects that you update to 1.3 or beyond must have this changed manually, or your app's not going to compile properly. Now, the relationship between the two files is established with a special tag in the XAML file called xClass. The value of this tag is the full type name of the class contained in the code behind file. The build process parses through the XAML file and creates a partial class that adds initialization and connector code into a .xaml.g.cs file that's also compiled into the application. If you change the name of the class, you need to make sure that you also change the X class tag to match, otherwise the application is not going to build. The code behind file in the .xaml.cs file will always have a call to the initialize component method in the constructor. This is the setup function that loads the XAML in from the resources and generates the object graph to display on the device. You won't find this method anywhere in your code. It's one of the things generated by the build process, and it will be located in a generated file in a temporary folder. It's typically the obj folder. The key thing to remember here is that the XAML file is processed by this initialize component method. And that means the object graph described by the XAML won't be loaded until after this method returns. This will be particularly important when we start interacting with those elements in the code behind a bit later. Now let's walk through the process of adding a XAML page to an application and how the initialization process works. Here we have Xamarin Studio with a brand new Xamarin.Forms application created. Let's take a look at our app file in C#. And you can see that we're setting our main page to be a new content page, and then we're going to set the content property to be a new stack layout, and in the stack layout we're going to set the vertical options and we'll add a label as one of the children. Our goal here is to change this from C# into XAML. So let's go ahead and do that. In our portable class library, which is the Forms demo project, we will add a new file, and this is going to be under the Forms tab, and I'm going to use the Forms content page XAML item template. We'll call this My Page is fine. And here in the Solution Explorer you can see that we have a mypage.xaml and a mypage.xaml.cs. Let's take a look at that .xaml file. Here you can read all the XAML. We have our XML namespace and we have our X namespace, including our X class. Notice that the X class matches the exact namespace and type name that is defined in our code behind. So forms demo.mypage. Again, our goal here is to create the same layout that we had in C#. Now we can either keep this content page.content or we can remove it. Let's go ahead and keep it for now. And I will split the screen so we can see exactly what the old page looked like. The first thing we had was a content page defined in our app class. Well, we have that here as the root of the XAML. The next thing we have is the content property, which we already have defined in our XAML for us. And in that content property, we're setting that to be a stack layout. We don't have that yet, so let's go ahead and add a stack layout to our XAML. The stack layout has a property set, which is the vertical options. Properties, remember, get set to attributes in the XML. And this will be center. And then inside our stack layout, we have some children. So we can use the property element syntax to define that. And we're adding a label here. Let's go ahead and add a label. That label has an X-align property, and that is set to be center. And we have some text, which we're going to say, welcome to Xamarin University. We'll change that so we can tell that we are actually setting the right thing. We've now defined the exact same layout as we did in C#. We've now set it in XAML. The last thing we need to do is we need to get rid of this C#, and instead of creating a new content page here, we're simply going to create a new My Page. We'll go ahead and run this. And there is our app running. We can run it in Android. Change over to iOS. and we can see it running on the iPhone as well. So let's take a look at our code behind for this file that we just created. We have my page, and in there we have a call to the initialize component. Let's go ahead and set a breakpoint on that initialize component and run this again, because nowhere in our code is initialize component defined. So what's going to happen here, we hit the breakpoint, and let's step into that initialize component and take a look at the file that we are in. We're now in the main page.xaml.g.cs. And here we have the initialize component method, and it's going to load from XAML. It calls the load from XAML method, which is going to read that XAML and inflate it. Well, where is this file located? Go ahead and open the containing folder, and you can see that it is actually in our obj folder, debug, and it's in this main page.xaml.g.cs file. That gets created by the compile process. So we can see how easy it is to translate our C# based object graph into XAML and use that to define our UI instead. An interesting thing happens with properties. You might have noticed that we use strings to set the property values. This is the only valid thing we can use for an XML attribute value. However, in most cases, the actual property value is not a string at all. Here you can see 5 properties being set, each with a different type. The label's text is a string. There's no conversion necessary in that case. The rotation property is a double, which can be converted from a string. The vertical options is an enumeration type, and it's matched to the name. Font is a complex type that uses a type converter, and color is a simple object, which also uses a type converter. Type converters have been in .NET since version 1.0, and they're used to take strings and turn them into some object type. You can write your own type converters and associate them to your own types to make them XAML friendly, but the system provides many of the common ones that you might need. Most of the built-in classes in Xamarin.Forms have associated type converters, so they can be easily created in XAML. For example, the font converter supports creating fonts using a modifier and a size, where the size can be a name, such as small, medium, or large, and that is mapped to the platform, or the font can be an explicit point size, like 36. The color type converter supports creating colors from the named color set available in code behind, or using the HTML hex syntax. The image converter supports taking a URL or file name to load an image, and the thickness converter supports the creation of a thickness object using a single number, 2 numbers, or 4 values for each edge. These variations match the constructors that you would use in code behind. Type converters are great for simple property settings, but in some cases we really need to create a full object with its own property values to assign to the property. Remember that in XAML, to create an object, we use an element tag. The solution to this problem is to change the property assignment to use an element-based syntax. This is called the property element form, and it involves breaking the property setter out into a parent-child form, where the property name is expressed in an element tag with the name type.propertyname, as shown here with the boxView.GestureRecognizer. The child tag is then expressed as an element tag, which creates the object and assigns it to the property. Anytime you need to create a new object, set properties on that object, and then assign that object to the property of another object, you can use this approach. Another interesting property type is the attached property. Recall that these are special properties which are not actually defined on the type at all, but are instead defined by some other object, typically the parent, and then added as a runtime value to each child. We use these for layout purposes to indicate where each child should be placed. Here you can see how we set attached properties in XAML. It looks like a normal property, except we have the owning type prefixing the name of the property. Anytime you see a type prefixing the property name like this, you know it's an attached property. With many types in Xamarin.Forms, you have a single property that is used to supply content. On a label or a button, for example, this is the text property. On a layout container, this would be the children property, and on the content page, this is the content property. These properties are almost always set, and so XAML allows for an interesting shortcut in their assignment. You can, of course, set them like any other property using the syntax that we've used up to this point. However, you can also set this property by simply putting the value between the open and closed tags of the object itself. For example, compare the top and the bottom examples. We can fully break out the content page.content property, or we can omit the property element and just set the label as a child tag. These will set up exactly the same object graph. This is referred to as the content property, and is established by little metadata added to the type through a custom attribute on the class definition. It's a nice convenience, particularly for layout containers, so that we don't have to use the property element syntax to set the children. One last thing we need to look at before you do a lab is how XAML knows what to create for a given tag. In other words, when it encounters a button tag, how does it know to create a Xamarin.Forms button control? The answer is XML namespaces. Xamarin.Forms associates almost all the built-in namespaces with the default namespace declared at the top of the XAML file. That's why you don't need to specify the namespace for a button as part of the tag. This definition will change for each technology that you work with. So for WPF or Windows Workflow, it would be a different namespace. There's a second namespace defined named X. This will be the same definition no matter what technology you're working with, and it defines all the available XAML keywords. We'll see one in just a moment. This is also where you will find the intrinsic CLR types, like strings, integers, and doubles. These two namespaces will be present in every XAML file that you create. XAML can actually create almost any object type, not just Xamarin.Forms types. To create a custom type, you need to supply the namespace yourself. This is done through an XML namespace tag. However, instead of a URI, you use a special syntax that identifies the CLR namespace and the assembly where the types that you want are located. The syntax you can see here is CLR-namespace, colon, and then the namespace of your type, semicolon, and then assembly equals, and your assembly name. The assembly name is the four-part assembly name: the simple name, the version, the culture, and the public key token, although it's often shortened to just be the assembly simple name. Note, this doesn't include the extension, so don't include the .exe or the .dll. The assembly portion is only required if the type is not in the current assembly. If you're creating local types that are defined in the same assembly as a XAML file, then you only need the namespace. You can still include the assembly if you like, but it's optional. You can define a custom namespace either on a specific element or at a root element where it can be shared across multiple child elements. Here you can see the definition for a system.collections.generic.list of t, where t is identified as a system.string. There's a couple of cool things here. First, unlike WPF, you can instantiate generic objects using the XAML keyword X type arguments to supply the specialization type. This comes from the XAML 2009 specification and is supported by the Xamarin parser. Second, notice that the string is defined as x:string. This is also part of the XAML 2009 spec, which defines all the basic intrinsic types in the XAML X namespace. You can, of course, also create strings by defining a custom namespace against the system namespace and MS Core lib, and that's exactly what we do on most of the Microsoft platforms, but with this support, that's not necessary. Now we're going to work on an individual exercise. This exercise will give you a chance to get some hands-on experience with creating a UI using XAML. Let's go ahead and open the starthere.html from the materials that you downloaded from the Xamarin University website. And we're going to start with exercise 1. Here you're going to create a XAML-based version of Calculator. Go ahead and read through all the instructions. This exercise is meant to take 30 minutes, but you can take as long as you need during this video. If you scroll down to the steps, you'll see that there is a starter solution in the Part 01 Resources Lab Start. And you'll open that starter solution, you'll rename the existing page, you'll add a XAML page to your project, and you'll create the user interface using XAML. Now, please pause this video, work on exercise 1, and continue the video when you are done. Now that you've completed that individual exercise, let's take a moment to review it. There is a completed solution in the materials that you downloaded, so if you had any problems getting this example to work, you can open the completed solution and follow along. So what we've done is we've taken all of our procedural C# code that was defined in our old mainpage.cs file here, and you can see this is almost 200 lines of C# code, and we've moved all that into XAML. We're going to use a grid control for our calculator UI, and we're going to create some labels and buttons. We'll set the attributes on those controls in order to set properties on the underlying objects. And we define our UI. If we look at our code behind now for this particular page, our C# is much cleaner, it's much easier to maintain, it's much easier to read and understand. And then lastly, we had to set in our app page, we have to set our main page property to be our new main page object. Now we're going to take a flash quiz. The flash quiz is meant to reinforce the material that we've covered so far. I will read the questions on the screen, and you should answer to yourself as we go through them. Question 1. XAML can be associated to a code behind file with which tag? Is it A, Xcode, B, Xtype, C, Xclass, or D, Xname? That's going to be Xclass. Remember, the Xclass tag needs to match the actual class and namespace in your code behind. Question 2. A mapping for a custom namespace named test in a data.dll assembly to an XML namespace named local would be which one of these answers? And I'll let you read those answers. The answer there is going to be D. We're going to set our XML namespace to be local, and then we'll use the CLR namespace of test with our assembly of data without the extension. Question 3. XAML uses what to translate strings to object values for properties? Is it A, value converters, B, type converters, C, property converters, or D, string converters? We use type converters to translate our strings to our object values for the properties. And question 4. Which of these is not a valid way to set the padding property? B would not be valid. The padding property is actually a thickness object, and we need to match the constructor parameters, and the thickness type, the thickness object, has constructor overloads that take 1 value, 2 values, or 4 values, but no constructor that takes 3 values. We've now covered how to add a XAML page to a Xamarin.Forms application, the structure of XAML and how to set different property types, how XAML identifies types, and the startup sequence. You've seen the basics of XAML and how to use it with Xamarin.Forms. Now we're going to look at adding programmatic behavior to the elements that we created. We have two main goals here. First, we need to see how to properly access the XAML elements that we're creating from the code behind file. Then we'll look at handling events being raised from the UI elements that XAML is creating. First, keep in mind that the object graph created by XAML is actually the same as your code behind class. In other words, you can navigate through the relationships in code by accessing the content property of your page and casting it to whatever you know that it is. In fact, you could pick off any object you like this way, but it's a very fragile way to identify objects because you're depending on the structure of the XAML without any guarantee or compile time verification that your assumptions about it are correct. The proper way to find elements created in XAML is to give them a name. This is done through the XAML keyword xName. This does two things. First, it adds a private field to the generated code behind file that will be mapped to this element, so we can use this field to interact with the visual element, setting runtime properties or handling events. You can see this here on the slide. It also makes the element known to XAML through a name, so you can refer to it from other elements defined in the same XAML file. We won't do this in this class, but you'll use this feature when we talk about data binding. Since this creates a field, you can't use any arbitrary string. Instead, it must conform to the naming conventions for a variable. And it also must be unique because it's going to be compiled into your code behind definition. Once you've provided a name for an element, you'll be able to interact with that element in the code behind file just as if you had defined it in your own code. Here you can see that we're hooking into the text change event for our phone number. One important thing to remember here is that the field won't be initialized until after the initialize component method is executed. So any code that interacts with the element should be placed after this call, as you can see here in the slide. And while it's not a common practice, you might decide to allow external users of your page object to access the visual elements created in XAML. You can do this easily by wrapping the private field in a public property. Now, a better approach to this would be to expose the actual data you want them to manipulate. For example, in this case, what I likely want them to be able to control is the text property. And in that case, I would want to expose just the string property from here, not the whole entry. Another way to wire up events is through an attribute in XAML. Attributes can either set properties, like we've done, or wire up events. The event must be public, because the syntax will simply add an event handler in the generated code behind, just like you might in your own file. Also, the actual handler must be placed into your code behind file, for the same reason, because it's being wired up in the partial class definition. The handler itself can be any scope, any visibility. Here it's private, but you could make this public, protected, internal, whatever you want. One point that needs to be made about event handling, though, is a separation of concerns issue. Wiring up events in XAML is convenient, but it mixes the behavior of the control with the UI definition. Many developers prefer to keep those things distinct and perform all the event handler subscriptions to be done in code behind accessing the named elements. This makes it easier to see what is hooked up and where the behavior is mapped to. It also makes it harder to accidentally break the code by removing a handler in the XAML without realizing it. That's not going to get caught by the compiler, and it will only show itself as an issue when the code doesn't perform that behavior properly. By contrast, if you remove a name off of a referenced element, the compiler will complain, and it will be immediately obvious that the code behind and the XAML are out of sync. You can use either approach. Pick the one that you prefer. And now we'll continue with another individual exercise where you're going to add some behavior to the XAML calculator that you created in exercise 1. Let's go back to our worksheet and open exercise 2. Again, you're going to continue working on the same solution that you started in exercise 1. If you weren't able to start that or finish that, there is a completed solution for part 1 that you can begin part 2 with. And you're going to come through and you're going to copy all the logic for the buttons and selecting controls on the screen from the old main page and add it to your XAML page. Again, follow the instructions carefully. This exercise is meant to take 15 minutes. So please pause the video and finish exercise 2. Now let's review exercise 2. Come back to our code. We can see in our XAML file we've now added some behavior. Each of our buttons has the onSelectNumber method wired up to the clicked event, and our onCalculate is wired up to our equals button. If we take a look in our code behind, then we have those methods: onSelectNumber, onSelectOperator, onClear, onCalculate, and those are going to perform our actual C# functions. Again, you can see the benefit here of keeping our C# focused on behavior and focused on things that C# is good for. XAML was designed from the ground up to declare and to create user interfaces. C# was not created for that purpose. It was created for logic and code. So we're going to put the bits of code where they belong, either in the XAML or in the C#. So if we go ahead and run this now, we can see that behavior, and we can see that we have a functioning calculator. So 5 times 8 equals 40, and then we can clear it back to 0. Now let's continue with another flash quiz. Again, I'll read the questions on the screen, and you can answer to yourself. Question 1. Putting an X name tag onto an element does what? Select all that apply. This could be more than one answer. Is it A, creates a private field in the associated code behind file? B, creates a protected field in the associated code behind file? C, makes the element accessible to other things in XAML? Or D, makes the element accessible in the code behind after the initialized component returns? The X name will create a private field in the code behind, makes the element accessible to other things in XAML, which we'll see in the data binding class, and makes the element accessible in your code behind after the initialized component. Question 2. Event handlers in code behind that are wired up in XAML must be public. Is that true or false? That's false. The event handlers can be any scope that you want. So in this objective, we've seen how to access elements in our code behind and handle events. Now, let's look at some more advanced things that we can do with XAML. We have 4 things that we want to look at in this final section. First, there are times we need to make minor changes in things like spacing or margins in the UI depending on the platform. We can do this in code behind with the device.onPlatform capability, and it turns out there's a mechanism for this in XAML as well. XAML provides an ability to share common property values like fonts and colors, which we want to be consistent across different elements. Next, everything we've done in XAML up to this point has been fairly static. All the property values are just constants that are set when the XAML is inflated and turned into an object graph. But sometimes we don't know the property value until the application runs. And so we'll look at a built-in mechanism to create extensions to XAML that can provide values for properties at runtime. And then finally, we'll look at a way to refactor our larger XAML pages into different shareable components through the use of a content view type. We'd often like the padding to change based on the platform. We can accomplish this through the onPlatform of type T tag, which allows us to specify 3 different values for iOS, Android, and Windows Phone. Here you can see the format. Again, we'll use the X type arguments XAML tag to specify the type being supplied. In this case, it's a thickness. And that's a known type in the default namespace, so we don't need an XML namespace defined for it. But you could have any custom type here as well. Then we'll have 3 different properties defining that type's value for each platform. If you don't supply a property, then the default value will be supplied. For example, here we could have omitted the Android and Windows Phone because 0 would be the default. When this code runs, the executing platform's value will be chosen and assigned to the padding property. If the property value can't be expressed as a string, then we'd break this out to be the full property element syntax to create a specific object to apply. This is a convenient way to supply simple values that need to change based on the platform. Now, much of your XAML definition will be known at compile time. For example, we often know where elements should be positioned and what colors and fonts will be used, and we either set literal values onto the properties or we let the platform make those decisions for us. However, sometimes we want to set a property value to something that can't be determined at compile time, a value that can only be known when the program is actually running. XAML defines a general mechanism for this called markup extensions. These are little classes which conform to a special interface named iMarkupExtension, which has a single method to provide a value. When the XAML parser encounters a markup extension, it creates the class, passes any supplied parameters to the constructor, casts it to an iMarkupExtension, and then invokes the single provideValue method to retrieve the final value to set the property. You can create your own markup extensions by implementing this same interface. It's a common way to extend XAML with new features and capabilities that aren't part of the platform. To tell XAML that we want to use a markup extension, we use curly braces to distinguish the value as something other than just a literal string. When the XAML parser hits an open curly, it assumes that the text that follows it is a markup extension, and it attempts to find a public class that implements the iMarkupExtension to provide the value. This means that if you'd like to actually use an open curly brace as the first character of a string in XAML, you need to escape the value. This is done by putting an open-close curly set in front of the string. This will be removed by the parser, and the final string here would be open curly, want a curly brace here, close curly. Xamarin.Forms includes a whole bunch of built-in extensions to provide runtime values from common places. For those of you familiar with Microsoft XAML, you'll find the same basic set of markup extensions here. So let's look at a few of them. One of the most useful built-in markup extensions is the XStatic extension. This reads a public static property or field from a specified class. This allows you to define values in code behind and then set them in XAML. For example, here we define a set of constants and then apply them to all of our properties. You could use this approach to define platform-specific values determined in code, or even to provide user-defined values such as profile settings, because we can define all that in a class in code and then just read the value with this markup extension. There's several other useful extensions included with the framework. We have static and dynamic resource. These are used to look up a resource in a resource dictionary. We're going to cover that feature extensively in the XAM130 class. We also have xnull, which is used to provide the value null, which is not the same as an empty string in XAML. We have xtype, that's used to perform a type of in XAML. The type object is created by the runtime, so it has no real definition at compile time, and therefore it requires a runtime lookup. Xarray is used to define an array in XAML. And binding is used to create a runtime data binding. We're going to cover that extensively in the data binding class. Now, if you find yourself repeating a block of XAML across 2 pages or have a fairly complex UI structure, you might consider breaking a portion of the XAML out into its own unique unit. This is done using a content view. Now, content view is a reusable XAML block, which can then be included on one or more screens. It's very similar to a user control in the Windows world or a fragment in Android. Content view works exactly the same as content page. It consists of a XAML markup file, which describes the UI fragment that you're building, and an associated code behind file where you can interact with that UI. All of the things that we've talked to up to this point work exactly the same way. The difference is this isn't a complete page, it's just part of a page. To use the content view, you have to include it in a page. This can be done directly, as you can see here on the slide, or it can be done through a template. You'll learn more about that in the XAML data binding class. In either case, you can add custom properties and events to the content view to allow the consumer of the view to customize the information or receive updates in the form of events. For our last individual exercise, we're going to finish our calculator solution by cleaning up the XAML code and tailoring the UI to the platform. Let's go over to our Start Here worksheet. Here we have the instructions for what we're going to do. We're going to create a resource dictionary. We'll move all the duplicate values that we have in our XAML. We'll move them into our resources. And then we'll create some platform-specific values for iOS. This exercise will be 15 minutes, but again, you have as long as you need. Please pause the video and come back when you're done. Now, let's take a look at that code that we changed for exercise 3 to clean up the XAML code and tailor it to the platform. Here in our main page.xaml, where we're creating our UI, you can see we've now added the on platform with, in this case, a type argument of thickness. We're going to change the padding of the top of the screen for iOS. So we'll use the onPlatform.ios, and we'll give it a little bit of padding up at the top so the status bar fits. Next, you can see in our content page.resources, we're creating a resource dictionary, and we're going to create a new string. We'll call that op button back color, and we'll set that value. And then everywhere that we use this, we're going to set the background color using a markup extension for static resource, and we'll set it to that op button back color. That will apply to all of those buttons, and it will allow us to change that value in one place and have it applied to all of the buttons. And you can see that here. This is a great way to start designing your XAML and organizing your XAML to work across multiple platforms. All right, now let's take one more flash quiz. Again, just answer to yourself. Question 1. To specify a platform-specific value in XAML, you use which of these? A, device of type T, B, on platform of type T, C, platform of type T, or D, X platform of type T. There we're going to use the onPlatform of type T method call. Question 2. To share a value, you can use which of these? Select all that apply. This could be more than one answer. Is it A, resource dictionary with the static resource markup extension? B, a resource dictionary with the xstatic extension? C, static properties in code and the xstatic extension? Or D, static properties in code and the static resource extension? We have two choices here. We could use the resource dictionary with the static resource markup extension, or static properties in our code and the xstatic extension. Question 3. Which one of these is not a system-provided markup extension? Is it A, static resource, B, xnull, C, image resource, or D, xtype? Their image resource is not a system-provided markup extension, but you could create your own markup extension to do whatever you need to do there. Question 4. To have a property value be set to curly brace text, you would type which of these? There we would have to escape the curly brace, so we would do open curly brace, close curly brace, and then whatever string we wanted to display. We've now looked at device-specific values. We looked at adding XAML to a project. We've looked at how elements create objects and attributes set properties in XAML. We can create any public object, even ones with parameterized constructors. We saw how to set names, wire up events, and add behavior. We talked about setting device-specific values with the onPlatform of type T. And then we finished up by sharing some values with resources and exploring some of the common markup extensions to provide runtime values. Thank you for watching XAML and Xamarin.Forms with Xamarin University. If you have any questions, please post a question in the Xamarin University forums or schedule some office hours with a Xamarin University instructor. Thank you, and happy coding!